This device here is called a ballistic pendulum, and it's a model of an old-time way where people used to measure the velocity of a bullet coming out of a gun by measuring how high it made a pendulum rise once the bullet hit it. So this is a classroom model, and that brass ball on there is going to get fired into this pendulum, and then we're going to see how high it rises. Based on the height, we'll be able to calculate the original velocity of the ball. So I'm going to stop the pendulum. We'll fire the gun. And now we can zoom in on here, and we can basically figure how high above the base of the device that this went. In the next few problems, we're going to look at how we can use this to figure out how fast the ball left the gun. It's important to recognize that this is not a simple problem, that there's actually several distinct snapshots in time that we have to look at. The first snapshot in time is when the ball is leaving the gun. The second is when the ball is just hitting the target and a collision is just happening. And the third is when it's all moved to its maximum height. In order to accomplish the problem, we're going to have to relate these snapshots to each other using separate problems. To relate the snapshot 3 to the snapshot 2, the best solution is to use conservation of energy, because the only forces here are the force from the pendulum arm, which is perpendicular to motion, and gravity, which is a conservative force. So that means energy will be conserved in this period of time between snapshots 2 and 3. But to relate the earlier part between when the ball left the gun and the ball collides with the pendulum, energy is not conserved. There's quite a bit of friction as the ball goes into the pendulum. So in these collisions where there are non-conservative forces, momentum is often a really good choice. And momentum is appropriate because although the ball puts a force on the pendulum also puts a force on the ball. So there's no external forces. So what we'll do is we'll do one problem to relate this position to this one using energy, and then we'll do a second problem to relate this position to this one using momentum.